Right, the Cambridge Computer Science guys. There is another software development process that you should understand, which is called rapid application development. So this is the third one. You have learned about SDLC, the traditional method of making software, and you have gone to learn the iterative model, which is a model which does a number of SDLCs one after another, scaling up the software from maybe rudimentary functions to advanced ones, right? So now we are talking about rapid application development. This is almost like iterative development in some sense, but the goal of this one is to produce a software product in a faster way. The goal is to make sure that in a very short space of time, the user organization or the users of the software are already having something that is working. So as they'll be using the software, you will also be creating a, a better version, scaling it up. Now, this one is more, a, what can I say? This is more tailored to the needs of the customer, right? When you are doing it, you will need the general functions, the requirements in the beginning. Then you firstly make a model. When you make a model, you don't negotiate much with the customer without a model. Most of the time, the customer will be commenting in terms of requirements from the model that has been made or that is already working, right? So, in this lesson, you are going to define rapid application development and explain the steps taken to carry it out, right? Then you are going to discuss the we are going to discuss the advantages and disadvantages of rapid application development in relation to other um, software development processes that we've talked about. That is the traditional SDLC and the iterative model, right? So look at the first definition that we've put there. We've said rapid application development model is based on prototyping and quick feedback with less emphasis on planning. Oh, there is a spelling mistake there. Don't worry. It was supposed to be it has less emphasis on a specific planning. You still remember that in our traditional SDLC, we concentrated much on planning to say when we want to develop the software, we actually need to know the functions of the software well beforehand. But at times, we have software products that are very complex that we can not precisely define how they are going to work. So if we have such kinds of software, maybe we specialize on developing models and we make the software better and better as it is being used until we introduce new functions that are a bit more complex or that cannot be described by either the client itself or the engineer. Then the second definition there we says this is a development a life cycle that develops different parts of the software requirements in parallel using prototype and providing early user involvement in testing. So what are we saying here? We are saying at times we may divide the organization into small teams. And when we divide the organization into small teams, each set of functions, then we group the functions of the software into smaller specific modules. Each team is working on a module, each team is working on a module to mean that the whole software is being worked out by different teams, each team making a smaller part of the functions of the software. After each team has made a seemingly independent module or application, we then integrate them to make a single software, right? So, do you see that a rapid application development in software can be done in maybe different ways depending on the organization, right? The idea here is to focus on quick delivery of software and at the same time, trying to actually make a software that is scalable in future, right? So look at the main features of a rapid application development process. People will do less planning, and then they make more effort, right, on the design and development. They prioritize models and prototypes, right, to mean that a in the early stages, analysis is very little. We simply get higher level requirements from the user and then we make a model. Most of the discussion in terms of requirements is now being done when the model is already there. We are commenting on the existing software in order for us to be able to generate new requirements and functions, right? Then the process, the emphasis on quick development. Maybe within a period of 2 weeks, we must be having something that can be installed on the customer's machine and the customer begins using the software, right? So look at the sample diagram there that I've given to say we have got some little planning there. Then look at the cycle there, which is like SDLC. We make prototype. When we make a prototype, we test it, we refine it. We make a prototype, we test it, we refine it. Each time we complete that cycle of prototyping, testing, and refining, we hand over to the customer the new prototype of model that we have, the software that is already working, right? So this is how a rapid application development model works. So look at the 4 major steps. Of course, like we say, to say rapid application development can be modeled differently depending on organizations and requirements. But there are 4 major steps which are requirements gathering, right? This process does not take much time. We focus more on prototyping. This is where the software model or the software framework is now being made, right? When we make a prototype, we discuss as a team of programmers and engineers, or we may even give it to the customer who then install and begin using it, right? As we discuss further functions or changes that can be made to the software. Then look, the construction of the software or development or coding, right? Then deployment. We deploy and then we do intensive scale testing, technical documentation, issue tracking, final customizations, and simulation testing, and so on and so forth, right? So these are the advantages of rapid application development. The requirements can be changed at any time. We don't need to have all the requirements of the software in the beginning like we do when we are using SDLC. It encourages priorities, it encourages and prioritizes the customer feedback, right? Development time is drastically reduced because some of the tasks will be running in parallel. So it actually means we are dividing the length of time to develop a software maybe by 2 or something like that. So the time between prototypes and iterations is very short. So we need to make several cycles, each time producing a software that can be scaled, right? So look at the disadvantages. We are saying it needs a strong collaboration because what are we saying? We are saying because requirements are being developed in parallel. To say if the software has maybe 10 requirements, we have created three teams, each team solving 3 requirements. Software is developed in parallel, which means the teams that are working on different requirements should now communicate openly so that when they are integrating the software, there shouldn't be little or no problems, right? Each team, of course, is developing the software separately, doing unit testing where they are developing it. But after that, we will need to integrate the software. The different modules and classes that have been created by different programmers, teams of programmers, should be able to integrate and work smoothly. So this is where the need for collaboration comes in. So it cannot work with large teams. So the example that I'm giving to say we have 3 teams, maybe those 3 teams should be very small to say each team has 3 or 4 people, less than 5, right? So that we minimize conflict and too much interaction, which makes organization very complex. So more complex, it is more complex to manage when compared to other models, because here we are saying teams are seemingly independent, but they are making the same product. So it actually means code that is coming from all these teams should be able to fit into one application, which is very complex. So we can say another disadvantage there is that only systems which can be modularized can be developed using a rapid application development. So you see, the meaning, the situation that each team is dealing with different requirements that will then need to integrate. It actually means that we may need to modularize the software, or to create classes to develop the software using object-oriented programming, which is a bit more complex when compared to other forms of programming that people use in a day-to-day life. So the implication is we should have highly skilled people, right? So, guys, this is rapid application development as a way of making software. The Zimsec guys, don't worry. This topic is mainly suitable for, is mainly required by the people who do a Cambridge advanced level. But it's still okay for you as a Zimsec student to actually make a follow-up, because you will understand what is called a prototype. You see, you need to understand prototyping, the Zimsec guys, and how it works. So a prototype is a representation of the actual software, or a miniature or a basic framework, right? From which the software can be scaled or fleshed up. That's the simplest meaning of a prototype. So please let us meet in another lesson next time. Thank you very much.